Okay, welcome back to day 2 of the review for Algebra 3-4. This message is brought to you in part by having a calculator, where you are not allowed to share a calculator on Friday, and you are not allowed to use a cell phone. That doubles as a calculator. You are only allowed to have a standard TI, whether smart or not smart, or the communist Casio calculator. Anyway, let's get back to the show. 139. The directions are, find the next 4 terms of each arithmetic sequence. Again, there were people on the quiz who overthought this problem. If it just goes 2, 5, 8, just tell me what the next 4 terms are. Don't give me a formula. Don't give me anything. It's just give me the next 4 terms. So does it make sense that the next term is going to be 11? And then it's going to be 14. And then lastly it's going to be 17, I'm sorry, 4 terms, so then it's going to be 20. And that's all there is to numbers 137 through 140. You're just writing down the next 4 terms. So this is actually going to be your answer right here. All right? Let's move on. Problems 141 through 143. Find the nth term of each arithmetic sequence. Let's see. Let's go ahead and do something like number 142. A sub 1 equals -3, D equals 32, and whoa, D equals 30. That's crazy. N equals 8. Remember, you will have a calculator on the quiz. So, if we're trying to find the nth term, then it's A sub what? A sub 8 is going to equal A sub 1, which is -3, plus D times n minus 1. So that becomes 7. We need 32 times 7. Where's my smart TI calculator? 32 times 7, and then minus 3. 221. So A sub 8 is equal to 221. And that is your answer. This is the first instance in which you're going to be employing the formula. Alright. Let's see. Okay, 144 through 146 is actually kind of odd. We never really directly did a problem like that in our homework, but we can look at it as though this was the very first example that I gave to you guys. Does it make sense that A sub 1 is 3 and that D is equal to 2? Okay? And that N is equal to, in this case, we're just trying to write an equation for the nth term. So in this case, if we're trying to find the nth term, then then N is going to equal N, right? Because we don't know which term they're asking for us. So A sub N is going to equal A sub N. So it's going to be A sub N is equal to A sub 1, which is 3, plus 2 to the, times N minus 1. So that would be writing the equation for the nth term. Problems 147 to 149. Find S sub n for each arithmetic series. Oh, that's easy. Okay. Let's take a look at something like 147. A sub 1 equals 3. A sub n equals 20. And n equals 6. So I'm going to plug this into my series formula, which you should have down pat by now, right? Yeah? So it's going to be S sub n, but in this case it's going to be S sub 6 equals n divided by 2. So that's 6 divided by 2 times A sub 1 plus A sub n. That becomes 23. That can't be divided by 2, so 6 times 23. 138 over 2. Oh, sorry. What am I saying? Divide that by 2. You could have just done that. S sub 6 equals, bam, first 2 numbers on the 3050Z's license plate. There we go. Okay, what did we just do? 147? Okay, let's take a look at something like number 151. So, we're trying to find the sum of each arithmetic series, so it's going to be 1 plus 4 plus 7 plus 10 plus ... plus 31. Remember, in a sequences and series problem, the only thing they can do to make it harder is to take away information from you. Here they've taken away a lot of information, but you need to fill in the parts. We know that A sub 1 equals 1. We know that A sub n equals 31. We don't know what n is, and we need to find out what n is in order to figure out the other the sum. However, we can tell us what d is. What's d in this, Carter? Got to be 3, right? Now, how do we use that information to find out n, Carter? Plug it into the sequence formula. So we get 31 equals 1 plus 3 times n minus 1. Now, what's the biggest mistake that I'm going to see happen right now? What's the biggest mistake that I'm going to see that I don't want you guys to make? What do you think? Riley? They're going to think 1 plus 3. They're going to say 4 times n minus 1. That's not correct. You're going to subtract 1 from both sides. So you get 30 equals 3 to the times n minus 1. Divide both sides by 3. You could have distributed. You'd end up with the same thing. So 10 equals n minus 1. So n equals 11. Okay? So now we're back to our regular work. So we say, what are we trying to do again? Oh, yeah, that thing. Trying to find the sum. So S sub 11 equals 11 over 2 times A sub 1, 1 plus 31. 32 divided by 2 is 16. 16 times 11. 1, 7, 6. And you are done with this problem. Am I moving too fast for anybody? We good? Okay. All right. Now it's 151. Okay, write the terms and all that good stuff. Okay, so let's say we're looking at 156. So we got sigma here. Remember, sigma means summation. Now, when it comes to the summation, it's telling you to write out the terms individually. Luckily, they don't give us that many. So that means you literally have to start at n equals 1. So when n equals 1, you have 10 times 1 minus 3. And then when n equals 2, you have 10 times 2 minus 3. When n equals 3, you have 10 times 3 minus 3. And when n equals 4, you have 10 times 4 minus 3. Now, oops, that's completely wrong. Minus 3. Now, does it make sense that I'm only going to go to 4 because that's my upper limit right here? I'm going to stop at 4, yes? We agree with that, Ayush? We agree with that? Okay, cool. So now it's got to figure out what these are. 10 minus 3 is 7. 20 minus 3 is 17. 27 and 37. And now, remember, sigma means what? Carter? Summation, which means we're going to add all these things together. So we get 7 plus 17. What do we get here? Ilyas? 88. So the sum is equal to 88. Duh? All right. Emily, thank you. Oh, no name. Ouch. When you don't put your names on the quizzes, it hurts a lot. Holy guacamole. 160. Find the next 4 terms of each geometric sequence. -9, 27, -81. Hey, real quick, are we going to use a formula in this one, or are we not going to use a formula? Carter? Not going to. What's the common ratio here between all these numbers? Carter? -3. So now you bust out your handy calculator, which, by the way, you can use, which, by the way, you cannot double as a cell phone, which, by the way, you can't share. So we go -81, 81 times 3, that's 243, times 3, 729, times 3, 2187, times 3 again, 6561. Now this is what we found. However, it was -3. So if you do it the way I did, you've got to remember that you have to alternate your negatives. So 243 was positive, which means 729 was negative, which means 2187 was positive, which means 6561 is negative. Okay? Don't worry, I didn't forget that. Now, find the nth term of the geometric sequence. Why don't we do something like number 163? That's going to be a bear. A sub 1 equals 5, R equals 7, N equals 6. Guys, sequences and series problems really shouldn't be, really should be the easiest part of the quiz, because the midterm, because you are just plugging stuff into the formulas, which you should already know. By the way, each midterm is going to have a blank sheet attached to it already in the back. The first thing you want to do when you get your midterm, tear that back sheet off, write all the formulas on there. Okay, so each sheet is going to have a blank page on it. Yeah? Cool. Thank you, comrade. All right. Okay, so now we're trying to find what are we trying to find? Oh, the nth term. Okay, so a sub n is going to equal, or actually it's not a sub n, it's a sub 6 is going to equal a sub 1, which is 5, times r to the n minus 1. So we've got 5 times 7 to the 5th. What do you think the mistake I'm going to see here is going to be? 5 times 7. That is wrong. It's 7 to the 5th, and then times 5. A sub 6 is going to equal 84035. And you're done. Remember your order of operations. Okay. What was that? 163? Okay, let's do something like 164. Throw a fraction in there. It's okay. A sub 1 equals 1 over 81. R equals 3. N equals 6. Now we're trying to find the sum. So S sub 6. This is where your summation for a finite geometric series comes in. You have A sub 1, which is 1 over 81, times 1 minus R to the N. Whoopsie. N in this case is 6, all over 1 minus R. Okay, 3 to the 6th. 729. So we have, let's see, 1 minus answer. So all this stuff here is going to become negative 728. Whoopsie. All over 1 over 81 divided by negative 2. So let's see, if I divide that by 81, I'm not going to get a whole number, am I? Nope. Okay, so I'm going to make this a fraction. Negative 728 over 81 times negative 1/2. So I get positive 364 over 81. Can that be divided? It cannot be. Done. If you get an answer that's if you get components in your problem that are a fraction, leave it as a fraction. If you get components in your question that are a decimal, leave it in a decimal. Okay. Do we really need to do 167 through 170? It's the same thing as the other ones, but it's just the same thing. Do we need to do one? Christian, you want to see one? All right, so let's do something like 168, because that one's kind of short. So, summation from n equals 0 to 3, 2, and then times 5 to the n. Okay, so again, we're going to write out all the terms. From n equals 0, that's going to be 2 times 5 to the 0, and then n equals 1, 2 times 5 to the first, n equals 2 is 2 times 5 squared, and then n equals 3, 2 times 5 to the third. Does it make sense? I'm only going up to 3 because that's my upper bound. Okay? Now let's just simplify it all. That's 1, so this becomes 2. 2 times 5, 10. 25 times 2, 50. Whoopsie. 50. And then 125 times 2, 250. And now sigma means what now? Summation. So I'm going to add them all together. So 312. Again, they're asking to write out all the terms, so it's all good. Okay, let's move on. It says here, find the sum of the infinite geometric series if it exists. Okay. Yeah. Okay, 0, n equals 0, that's where you start. That's why we started at n equals 0. Unlike the arithmetic series in this, we start at n equals 1. This thing just tells you where to start at the bottom. Yeah or no, Esther? Yeah, so you start wherever it tells you to start. So okay, so let's say I had a summation up to 100 and n equaled 88. Where are you going to start, Esther? 88. And let's say it was like 5n plus 3. You'd start at 5 times what? 88. All the way up through 100. I can't hear you. It's the same for problems what now? Yes. Okay, so now, okay, find the sum of the infinite geometric series if it exists. So we have to find out whether or not it exists or not. Let's take a look at something like number 174. 49 plus 14 plus 4 plus dot dot dot. Okay, we know that a sub 1 equals 49. How do we find r in this problem? How do you find r in this particular problem? Because they took away a lot of information from you. How would you find r? That's the hardest part. If you don't know how to find r, you're going to be in a little bit of trouble. Rachel, what do you think? Divide one of the numbers by the one previous. So how about 4 divided by 14? That's 2 over 7, yeah? So, what do you think? Does this series converge or does it diverge? Oh, there are some words you haven't heard in a long time. Does it converge or does it diverge? It diverges, so there's no sum, right? No, it converges because the ratio is in between -1 and 1, so it converges. So, can we find a sum to this thing? Okay, so we say that S, because it's just standard S, equals 49 over 1 minus 2 sevenths. So you get 49 over 7 over 7 minus 2 over 7 is 5 over 7. So 49 times, oh man, I wish it was the other way around. That way they could cancel each other out. That's okay. 49 times 7. 343 over 5. Take a look at something like number 175. 3, -9. Whoops. 3 minus 9 plus 27. Dot, 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 dot. Okay. A sub 1 equals 3. R equals, what's R? What does R equal, Hannah? -3. Hannah, what do you think? Doesn't work. Why not? Now, you guys got to be careful when you explain this. Hannah, go ahead. The absolute value of R is, Daniel? Therefore, the series diverges. And therefore, no sum exists. Remember, on the midterm, I want to see this, I want to see this word, and I want to see this expression in some coherent English order. So you can't just say, no sum, the series exists, diverges, R is greater, absolute value of R is greater than 1, therefore. Okay, can't do that. Okay? You'll get it wrong. Okay. Repeating decimals as fractions. 177. Zero point 0.12121212. Okay. So, a sub 1 is going to be 0.12. A sub 2 is going to be 0.0012. What's a sub 3 going to be? Not that we need to find it, but what is a sub 3 in this case? Hannah? You missed a 0, but it's 0.00012. Right? Right, Hannah? Because if we flatten this whole thing, it's going to be 121212, right? Cool. Okay, so now, you guys have the calculators. You tell me what R is. Take 0.0012 divided by 0.12. 0.01. Do we have all the information we need? We do. S equals 0.12 over 1 minus 0.01. 0.12 over 0.99, I believe. I'm always bad with decimals. Yes. Now, multiply both by 10, so we get 12 over 99. Divide both by 3, you get 4 over 33. Please reduce your fractions. Let's take a look at something like number 183. What does the top expression mean? 70! What does the top expression mean? You want me to yell at you? 14 times what? Esther. All the way down, right? Okay, did I miss one? 14, 13, 12, 11, 10, 9, 8, 7, 6. Okay, cool. All right, so now the bottom becomes what? 70! Times blah, 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 blah. Now, I really don't need to include 10 through 1 because what's going to happen to all those things, Riley? They're all gone anyways. We don't care. Now, does it make sense that 4 times 3 is 12? And 2 into 14 is 7? So what you have now is 7 times 13 times 11. So we can do that in a calculator. 1001. Raise your hand if you got 1001 as your Porter. What's up? Please do not use your calculator. Show me this. Okay. Stephanie, how you doing? You all right? Okay, good. Hannah, what's up? What do you mean? What do you mean? I want you to at least show me the top. That way I can see what's going to cancel up at the top. But like, remember what I did on the bottom, like 10 all the way, and then I did like those kind of squiggly lines to 1? That's fine. As long as it's on the bottom. You know what I mean? But I do want to see the whole factorization of the top. For a minute there, I thought I saw 183 factorial. I was like, wow, that's wrong. Well, you'll get it right, but it's just wrong. Okay, let's do something like number... Okay, you know what? I'm going to backtrack. I'm going to do these in reverse order. I'm going to do 192 through 196 first, and then I'll do the binomials, so I'm going to do 2 of those. So, let's take a look at something like number 193. We want to find the 7th term of 2x minus 3y to the 10th. Now, that's huge. I'm going to go and write the formula out just so that we know it. It's going to be sigma from k equals 0 to n, and it's going to be n factorial over n minus k factorial, and then a to the n minus k times b to the k. Wow, that's a mouthful. Okay, so in this problem here, we only have to identify what n and k are. What's n? What's n in this problem here? N is the upper, Cameron? No, it's not, actually. Hannah? It's 10. Cameron, remember, n is always the exponent that you see. And then what is k? K is the only one that you really got to remember. Hannah? It's always one less than the term they're asking you. Okay? So now we just plug it all in. So we say the summation from k equals 0 to 10 of 10 factorial over n minus k, so it looks like 10 minus 6 factorial times k factorial, and then a in this case is 2x to the n minus k, so 10 minus 6, and then negative 3y, whoopsie, to the k. K in this case being 6. Guys, remember to keep your terms in parentheses, otherwise you're going to end up with some messy answers. So let's take care of the coefficient first. This is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all over 4, 3, 2, 1, 6, all the way through 1. So Hannah, basically, if you structured it like this, I'd be fine with that. Bam, those are gone. Bam, those are gone. 4 times 2 is 8. 9 divided by 3 is 3. So you get 30 times 7, 210, times 2 to the 4th is 16x to the 4th. And then 3 to the 6th, was that like 729 or something like that? Yeah. Good job. Thank you. 729y to the 6th. Now, all we have to do is figure out what 210 times 16 times 729 is. Good thing you guys have calculators, which, by the way, can't be shared, which, by the way, can't double as cell phones. Hannah, what'd you get? Two four four 9 4 4 0 x to the 4th y to the 6th. Yes? Esther, what's up? Yes, yes. 10 minus 6 became 4, and this is where the 4, 3, 2, 1 came from. Yeah. Oh, you have to. Yeah, you have to do that. Koki, what's up, buddy? Uh-huh. Oh, you know what? For these, Koki, I personally find that using the Pascal triangle is faster. To the 5th. Wait, why don't we just do that one real quick? Okay, so I would say, yeah, Rachel, what's up? Oh, I'm sorry, yeah. Okay, let me pause also, and then Koki, and then I'll explain it to you, okay? Okay, for number 187, personally, I find the Pascal triangle to be faster, so I'm going to go 1 like this. That's to my 4th power. To my 5th power, this is where I want to be. So my coefficients are going to be 1, 5, 10, 10, 5, 1. Each one gets a term, so an x and a y, an x and y, x and a y, x, a y, x, y, and an x and a y. And then remember, the x term, the a term, exponents start high and go low, so the highest exponent is going to be 5, then 4, then 3, then 2, then 1, then 0. Then y is going to go 0, 1, 2, 3, 4, and 5. From here, you just simplify it. So all of this junk's going to go away, and that's going to go away. You get x to the 5th. You get 5x to the 4th y. 10x to the 3rd y squared. 10x squared y to the 3rd. 5xy to the 4th, and then y to the 5th. And since they're all positive, 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 positive. And you are done with that answer. Esther, whether they're positive or negative? Okay, so if we took a look at something like, say, number 190, okay? Can we do that? Can we do 190 real quick? Even though it's a little kind of nasty. Okay, 190, Esther, is to the 4th power. So I'm going to use my 4th term, which is right here, yeah? Okay, so that's going to be right here. So 14641 looks like my coefficients. So in this case, each thing gets a term, right? So this is going to be x over 2 and then negative 3y. Esther, so far so good? Ah, darn it. Ah, that's ugly. So far so good, Esther, even though the handwriting's kind of nasty? Okay, so now, again, it's going to follow the same pattern, Esther. So the first one's going to get a 5, sorry, not a 5. In this case, it's going to get a 4, right, Esther, because the highest exponent was 4 on that one. And then 3, 2, 1, 0. And then the second term is going to go from 0, 1, 2, 3, 4. Now from here, Esther, you just have to use some math. So here it's going to be, that's going to go away. You get x to the 4th over 16, right? Because 2 to the 4th is 16, yeah? And then here you're going to get x to the 3rd over 8 times negative 3y to the 1st is negative 3y. But that's all being multiplied by 4, right? So those can cancel out, leaving me with a 2 on bottom. So I end up getting 2x to the third y. Just kidding, what am I saying? I'm obviously not with it. The top's going to multiply with the top, so I'm going to get negative 3x to the third y over 2. Okay, now because this thing's negative right here, Esther, it's minus. Okay? And now, this is going to become x squared over 4 times 6 times, let's see, this is 9y squared. So those are going to cancel. I'm left with a 2 on bottom and a 3 on top, so that's going to be over 2. 3 times 9 is 27, x squared, y squared. And because I squared a negative, Esther, it's going to be positive. Okay, so that's all gone. And now this is going to be 27y to the third. This is x over 2 times 4, so that's going to leave me with a 2 up top. So 2 times 27 is 54 x y to the third. Now, because I raised negative 3 to the third power, it's negative. Okay? And then the last one, that's all gone, plus 81y to the fourth. And the reason why it's plus, Esther, negative being raised to an even power. Okay? Cool. All right. There you have it, people.